Welcome to Steve Freeze Academy Nutrition Center. I want us to do physics today and waves. So, we talk about wave. We say that sometimes they can ask you to define the wave. So, I'm saying that a wave is a disturbance, or it's any disturbance. It's any disturbance caused through medium. So, I'm saying that a wave is any disturbance caused through medium. Yeah. So, and the same wave, a wave, in fact, a wave can transfer energy from one place to another. Yeah, so a wave is any disturbance caused through medium. Then the same wave can transfer energy from one place to another. Then types of waves. Yeah. So we have two types of waves. Number one, which is transverse wave. Number two, longitudinal wave. So these are two types of waves: the transverse wave and the longitudinal wave. Then we'll start with the transverse wave. So when they ask you to define a wave is any disturbance caused through medium. Then the wave can transfer energy from one place to another. At the same time, there are two types of waves, which is the transverse wave and longitudinal wave. So you need to know this type of waves, in fact, which is transverse and longitudinal wave. Yeah. Then we now define the transverse wave. Transverse wave, the type of wave in which the vibration of particles are at right angles. Yeah. So transverse wave, the type of wave in which the vibration of the particles are at right angles, or if one can say perpendicular to the wave direction. So in short, this type of wave they make 90 degrees. This is a 90 degree. Perpendicular means 90 degrees. So they make 90 degrees. Yeah. So the diagram of a transverse wave, or before that, maybe say examples of transverse wave examples. So number one, we have water wave. Number two, we have wave on the vibrating fork. Number three, we have electromagnetic electromagnetic waves, which are examples of electromagnetic wave. We have examples we have read. As for me, I always remember using what called the memory aid. You say rotten mango is very an XY. So all these. So M stands for radio wave. Radio wave. Then this stands for microwave. Microwave. This stands for infrared. Infrared wave. Visible light. Visible light. Ultraviolet. Ultraviolet light. Ultraviolet light. Ultraviolet light. This is the X-ray. This is the gamma ray. So these are examples of electromagnetic wave, and all these are transverse wave in nature. So I have electromagnetic wave, which are radio wave, microwave, infrared, visible light, ultraviolet, X-ray, and gamma ray. So as for me, I use what we call the memory aid, which is the R stand for rotten mango is very an XY. So rotten mango is very an XY. So this is a radio wave, microwave, infrared, visible, ultraviolet, X-ray, and gamma ray. So this is just my memory aid that I used to memorize the order of the electromagnetic wave. Because sometimes in the final exam they can remove this part, maybe on this part. Then they'll try to ask you identify this part, which is part M or part Q or part Q. So I'm supposed to know the order from here, go this direction. Or sometimes they can start from the other end. They can say rotten mango is better than XY. So you need to know the order in short. Yeah. So these are some of the examples of a transverse wave. Transverse wave. So in short, if they ask you, give an example of a transverse wave, which are electromagnetic wave. So you can list maybe a radio wave, microwave, infrared, whatever. You can give one example, two examples from there. Then we'll ask you to state the examples of a transverse wave, which are not electromagnetic wave. So now we can say water wave, wave on the vibrating fork, etc. So these are examples of even wave on the rope. You can add it here. Wave on the rope. Wave on the rope. Rope, yeah. Rope is also a part of the transverse wave. When I go to the diagram of a transverse wave, maybe I put what here? I put the 4 here meters. I put the 4 meters here. 4 meters. 0 here. I do like this. I do like this. I do like this. I do like this. Like this. Yeah. So this is diagram of a transverse wave. Transverse wave. Yeah. So we need to know the parts. So the lowest point of the wave, this part, we call it trough. So trough is the lowest. The lowest. Sometimes you can say minimum. Minimum point of the wave. Of the wave. Good. Then we also have this part. This part which is crest. The crest is the highest. I can say the maximum point of the of the wave. Yeah. So crest is the highest point of the wave. Then the distance from here up to here, as you can see, 0 is 4. So the maximum displacement, you can call it amplitude, amplitude. So amplitude, I will define from here. Amplitude is the maximum displacement of the wave from its rest position. So it can be also minimum. So this amplitude and also this part can be amplitude as well. So it can be amplitude as well. Amplitude. So distance from here to here or from here to here, we call it amplitude. Then the diagram for a complete circle is a circle. It's a circle, the circle, the circle. This is a circle, the circle. Then when you cut it here, it will be half of the circle. So this is half of the circle. Again, half of the circle. Then the complete circle made from half plus half is one circle. So the distance from here to here, we call it distance from here to here. We call it wavelength, given by this symbol, which is called lambda. So this is wavelength. So wavelength is or maybe you can say, as you can see from here again, from here, half again, half here. So distance from one crest, this is a crest, from one crest from here up to here. So distance from crest to another crest here. From this crest to another crest here. From here to here. We also call it wavelength. So wavelength, you can say wavelength is the distance between two successive crest. So wavelength is the distance between two successive crests. So we call it wavelength. So distance from here to here or from here to here. Or you can say the distance at which a wave repeats itself. We call it wavelength. Then the S sign for wavelength. The S sign for wavelength. The sign for wavelength. The SI unit. The SI unit is the meter, which is a meter. Then apart from that, wavelength is given. It is given by a Greek symbol. This Greek symbol, which means lambda. So this symbol, in fact, the one which is on the diagram, we call it lambda. It's a symbol for wavelength, in fact. Hope it's clear. Yeah. So, in short, here I've defined the amplitude, which is this one, distance from here to here, and also from here to here. Also the wavelength from here to here, and also the trough, which is the minimum point of the wave, and also the crest, the highest point of the wave, and the trough there. Then I go to frequency. Frequency is the number of waves made per second. So this is the definition for frequency. So frequency, the number of waves made per second. So when they ask you to define frequency, say frequency, the number of waves made per second. At the same time, we know that frequency is measured in SI unit is hertz. Hertz, which is Z. It is like this. So frequency is equal to number of wave over time. This is the formula for frequency. If you want, you can also there's this formula. Frequency is equal to 1 over period. So talk about period. This is the time taken for a complete wave. So frequency, period, the time taken for one complete wave. So this is the time which is measured in second. So I can use this formula: frequency is equal to number over time, or frequency is equal to 1 over period, which is the time given in the period. That is clear. Then I'll go straight to let me give my example now on examples of longitudinal timeless. Of electromagnetic wave. Waves. So I said I'll draw a box like this. That can be clear. So I'll put here radio wave. So I said the rotating angle is very XY. So radio wave, microwave, infrared, visible light, ultraviolet light, X-ray, and lastly is gamma ray. So these are examples of what electromagnetic wave, and are part of timeless wave. So as we know from this side, going this to the right hand side, the frequency increases, right? So a radio wave, it has got the lowest frequency, in fact. Then the gamma ray there, it has got the highest frequency. Then again, as we move from this going to this side, the wavelength increases. So again, radio, it has got the highest wavelength compared to gamma ray. Then properties of these waves, the O obey the wave equation, which is the velocity is equal to frequency wavelength. This velocity, which is the speed. This is the frequency. This is the wavelength. So all these waves, they obey the wave equation. Number two, they all move in a vacuum at a speed of light, which is 3 times 10 to the power 8 meters per second. So all these waves, they have got the speed of 3 times 10 to the power 8. That's the speed of light. Okay. So sometimes they can ask you, they can remove this part and also remove this part and identify, and just try to identify this component and also that component. So as a student, you're supposed to know all the parts there. Longitudinal wave. So this is the type of wave. This is the type of waves in which the vibration of particles are parallel to the wave direction. In short, these are parallel like this, this and this. And a very good example of longitudinal wave is sound wave, and also earthquake. Apart from that, also we have wave on the spring. It can be part of longitudinal wave. Then the diagram for this type of wave is, I'll just do it simple. You can see the particles are closer to each other. They are far apart. Again, closer to each other. Again, here far apart. Again, closer to each other. Yeah. So this is just a simple demonstration here. Okay. So as you can see, the particles here are closer to each other here, and this region we call it compression. So this is the part of the wave, which is the longitudinal wave, where the particles are closer to each other. So the place in a longitudinal wave where the particles are closer to each other. Then again, this region here, where the particles are far apart, we call it function. So the place where the particles are far apart, they're functional. So it's a region in a longitudinal wave where the particles are far apart. Then the distance from here to here here to here. We call it amplitude, amplitude, amplitude. The distance from here to here is called amplitude. Then again, the distance from here to here, from one compression to another compression, or from one refraction to another refraction, we call it wavelength. Yeah, so we need to know all these things. So for now, we can end here. I'll try to send some questions before the end of this day. Thank you very much.